Hello everyone, this is Udaditya from TechSpark. I have been working in data engineering domain for almost 9 years with various projects and involved in creating data pipelines for several clients. I also train candidates in this field to help them build an interview-ready profile with a comprehensive course covering all the necessary topics of data engineering. In today's session, we're going to discuss about Yarn, which is known as yet another resource manager, and how it works as a cluster manager for our Hadoop ecosystem. Now, our big data files are located or residing in the Hadoop data nodes, right? When we talked about Hadoop in the previous session, we saw that there are different master slave architecture, which has the combination of name node and the data node working together to serve the clients for any read or write operation. Now, we know how to read or write data from and to the Hadoop cluster. We know where the data are located and specifically in the node manager. But what if we want to process the data? What if we want to submit any application on top of the data that is residing in Hadoop? In that case, Hadoop has no role to play. It simply works as a file manager or a file storage. Now, to handle or to utilize the cluster resources such as the RAM, hard disk, vCPU cores, whenever we submit any application, be it Hive or Apache Spark, to process the big data that are inside the data nodes in our Hadoop cluster, we need some form of a cluster manager which can negotiate with the master slave architecture and also fetches the resources that are required to submit the same application. Now here's why Yarn comes into play to help in submitting and also monitoring the application while it's running on the Hadoop node. So Yarn has some key components such as Resource Manager, Node Manager, Application Master, Container. So we're going to talk about each and every one of these components one by one and understand how these components cumulatively help in running any application in Hadoop. So the first one we want to talk about is the Resource Manager. Now, before talking about Resource Manager, let me give you a brief idea how Yarn works. It has a similar kind of a setup as Hadoop. Hadoop used to work as a master slave architecture using the name node and the data node, whereas in Yarn, there is the resource manager and the node manager. Resource manager is the master which provides all the instructions to the node manager in allocating the resources and also submitting the application. Now, if I talk about Resource Manager specifically, it is the master daemon of Yarn and it is responsible for resource assignment and management among all the application. Whenever it receives a process request, it forwards to the corresponding node manager and allocates resources for the completion of the request accordingly. Now let me talk about the node manager. It takes care of the individual node on Hadoop cluster and manages application and workflow in that particular node. It registers with the resource master and sends heartbeats with the health status of the node. So if I say there are 10 nodes in the Hadoop cluster, one being the resource manager where the resource manager is sitting and the other 9 where the node managers are sitting. So if I submit an application, in that case, the master one or the resource manager will take that application request and then it will ask each and every node manager in individual node where it can allocate some specific resources. And those resources are nothing but the commodity hardware resources such as the RAM, hard disk, CPU cores, and etc. So that's how Resource Manager basically instructs the node manager to find out the nodes where the specific resources are available at that moment whenever an application is submitted in the Hadoop cluster. Now let's talk about Application Master. It's an application in a single job submitted to a framework. The Application Master is responsible for negotiating resources with Resource Manager, tracking the status and monitoring progress of a single application. So it is kind of a right hand of resource manager where it directly connects with the resource manager, then it goes to the node manager and then submits or runs the application once the resources are allocated. Now, if I talk about the final thing, that is the container, it is a collection of physical resources such as RAM, CPU cores, and disk on a single node. The containers are invoked by container launch context, which is a record that contains information such as environment variables, security tokens, dependencies, and etc. So container is the singular unit or the granular unit of yarn where application or each and every chunk of the application will be running. So each and every node will have node manager, and inside node manager there will be a portion of the commodity hardware resources that will form a container. So if I talk about, there are total 9 nodes. Inside all the 9 nodes, there will be each and every node manager running in different 9 nodes. And also each and every node, there will be one part of it uh, or one single abode where the application, a chunk of application will be running. So that is known as the container. So let us now see how Yarn actually looks, how Yarn actually works and helps in submitting and also running the application in the Hadoop cluster. First of all, client being me, if I try to submit any Hive or Spark application, me being the client who's submitting a job in the Yarn using the Hadoop resources. So client submits an application. Okay. Now next what happens? The resource master or the resource manager allocates a container to the start of the application master. Now the resource manager, what it will do, it will start an application master in one of the node manager. The application master negotiates containers from the resource master. Now resource manager will spawn an application master, but it is the duty of the application master to negotiate with the resource manager to get some specific allocations or to get some specific CPU cores, RAM, or the memory that is required to run the application from any other node, from any different node. So that's how the application master connects with the resource manager, then gets the specific requirement, such as all the commodity hardware resources from each and every node manager. The application master notifies the node manager to launch containers. The application code is executed in the container. The client contacts the resource manager or the application master to monitor the application status. Once the process is complete, the application master unregisters with the resource master. So that's how it is. So if you look at the diagram over here, the client is submitting any application, then it directly connects with the resource manager. So the resource manager has two parts, the scheduler and the application master. I'll come to the scheduler part later, but let us talk about the application master. Now if you see, the application master is being spawned or being redirected to each and every node. Now let us consider this rectangle a node, just like the other two. And inside the node, there will be a node manager, which is also a daemon running. Now, once the application master connects with the node, then it has the accessibility of all the resources in this node. Now, what it will do, it will simply get the instructions from the resource manager, and then it also tells the node manager that this node's resources, such as the CPU cores or the RAM, can be used for the application running. So similarly, this will spawn in other nodes. As we know, in big data, things or application or processes are not running in a single node. That is the beauty of it. That's the significance of having a distributed ecosystem where we will be running multiple, where you will be utilizing multiple node resources and run the same application. So that's how only a portion or chunk of the application will be running in each and every node. So just like this one, the application master will go into two other different nodes, and it will get the instruction or the approval from the resource manager whether or not to use the cluster resources of this same node. So once it gets, then the node manager will allocate the resources. The node manager will allocate the resources, and then it will spawn a container. So this container is having the ultimate commodity hardware. So suppose this node has about 64 gigabytes of RAM, and it has say 16 CPU cores. Okay, now my application, it requires say 32 GB of RAM and also 8 CPU cores. So what will it do? First, the application master will ask the resource manager or get the approval from the resource manager whether it can use that 32 GB of RAM and 8 CPU cores from this node. So once upon getting the approval, then it will ask the node manager, hey buddy, I need 8 CPU cores and 32 GB of RAM from your node. Can I get it? So node manager will simply say, yes, it is available for you now, and he provides the container. Now over here in the container, the application master will spawn its process and then it will start running. So that's the gist of it. That's how Yarn basically utilizes the Hadoop cluster resources and helps in submitting and also running the application, be it Apache Hive or Spark or any other application that is using the Hadoop data or the Hadoop resources. Now, there is one more thing you might have noticed that I just say that I'll be talking about it later. That is the scheduler. So what does scheduler work over here, or how does scheduler basically works in the Yarn? Let us see that as well. Okay, so there are three different kinds of scheduler. As you can see, one is the FIFO, second is the capacity, and third is the fair scheduler. So FIFO is kind of like self-explanatory how it works. It is termed as the first in, first out, meaning if I have two jobs or two application running in my yarn, and if the scheduler is set to be a FIFO scheduler, meaning first in, first out, in that case, it will allow the first one come, then it will run, and then the second one will be waiting for it. Okay, and no matter how much the first one takes time, once the first one is completed, then only the second one will be launched. So that is the FIFO scheduler. Now, is it a good approach of running jobs, like multiple jobs in the same cluster? Let us talk about an example. Suppose I am running an application or job that would take around 60 minutes, like an hour, and another job that is being submitted by another client or someone else in the same cluster that usually takes around 5 minutes. But since I submitted the job, so he has to wait for 60 minutes. So once my job completes, then only the resources will be free, and over there, the second person can come and submit the same job. So you can see for a 5-minute job, he or that person has to wait for 60 minutes for my job to complete. Then only that person can come into play. Now to overcome that, there is another thing that is called capacity scheduler. It is a scheduler that divides the cluster resources into multiple queues, each with its own reserved resources, while able to dynamically utilize unused resources from other queues. It is suitable for large-scale multi-use environments. So over here, again, the same scenario. So there is one job which is taking 60 minutes and the other job which is taking 5 minutes. Now, if the cluster resources are divided, okay, so what happens, say 60-40, it is divided. Now 60% of the resources that I'm using, because my job takes about 1 hour, and 40% resources has given to the other person, which takes about 5 minutes to complete the job. Now the fact of the matter is, it would have been better, it would have been sufficient if I was given 95% of the cluster resources and the other person was given only 5%, because that would take very less amount of time. Whether I would take a little bit more resource, my job would take a little bit more resource, considering the way it is handling the data or the kind of processing it is being done upon. So over here, it is a bit, I would say, bringing justice to the other user, but not in a very authentic way or in a very accurate way, because because the other person or the less or the short job has been given like 40% of the resources, even if it doesn't require that much, and my job, which takes a lot of resources, and I have been given 60%, which is more than him, but still it's not sufficient. So to overcome that, there's another scheduler which is known as the fair scheduler. It is a scheduler that is designed to balance resources fairly and equally among accepted jobs. Without requiring a set amount of reserved capacity, it is suitable for the cluster that runs jobs with varying sizes and resource requirements. Now over here, what happens is that each and every job gets its own fair share of resources. So both the jobs submitted at the same time, or maybe the job two or the second person submitted a job a bit later. I submitted the job first, even though my job takes a bit of time, but still only the required amount of resources that the other person need or the other job needs will be given to him. So for that amount of time, only for 5 minutes, I will be having some less amount of resources. Suppose in the node or in the container where both the applications are running, so there are say 50 GB of RAM is there. Now, when I just first submitted my job, it is utilizing the whole 50 GB of RAM. Okay, now the next person comes, he would require say 5 GB of RAM. He started running the job. Now he's getting his own 5 GB of RAM, and I'll be getting the list 45 GB of RAM. For 5 minutes, I'm using 45 GB of RAM, and the other job is having 5 GB of RAM. So once that 5 minute is over, then his job is simply out of the picture, and then again I'm using the 50 GB of RAM. So that's only for the requirement amount or specific amount of time I'm having less resources, but still it's not that less as if I talk about capacity scheduler, if I compare with the other one, where for throughout the job I'll be getting less amount of resources. But now only for that period of time I'm getting less amount of resources. So that's how it basically deals with different kinds of jobs in a single yarn container, have dealing with different schedulers. And for my opinion, fair scheduler helps a lot when we are running multiple jobs in the yarn and submitting all the application in the same cluster. So that's all for today's session. You might be wondering, how do we submit why high application or Apache Spark application on Yarn, and then how do we monitor the same application in Yarn UI? To know more, reach out to TechSpark. We provide all the necessary to we provide a thorough course covering all the necessary tools in our data engineering course, such as Spark, Hadoop, Hive, AWS, with hands-on coding and real-world project. Signing off for now. See you on the next session. Goodbye.
Contact us for the free job assistance. We will help you to get the IT job. Please like, subscribe, and share the channel for more regular updates from TechSpark.